So I know where all the bodies are, I mean, all the. So what I'm gonna do is, how many of you, everybody, people got water license, they know where water comes from. You know, our water's artesian, right?
Yes, sir.
Memphis' water's artesian, most of West Tennessee is artesian in some way, shape, or form.
If you want to speed up on some, that's fine, you know.
So, yeah, I'll skip some of this. Y'all seen this? I stole this from UVM. It's way, you know where the water comes, basically.
Yep, this is the city of Memphis, this little dot.
Yeah, Doug, the guy that did that at University of Memphis squeezed that in to try to show all the different layers of aquifers. You know, we've been through a lot of that around here lately because of our next door neighbors and wanting to take water out of the aquifer. And so now they're constructing the water treatment plant next door to use our effluent to make cooling water for them.
How many states is the Memphis aquifer under? You know?
Mississippi, Tennessee, Arkansas.
I thought it ran all the way up to
It goes
Kentucky, all the way down to far middle Mississippi, and as far as eastern Arkansas.
It goes over in Arkansas, but I know how far into Arkansas.
Yeah.
But water typically flows that direction. There is some crossover under the river apparently that they don't like.
Yeah.
So once upon a time in Memphis, stop. All right, Chris, what you do this? What is it going back there? Okay. All right, so once upon a time in Memphis, all the water came out of the Wolf River. They took all the drinking water out of the Wolf River, and if you go, if you're familiar with Memphis at all, this pumping station was right above where Mud Island is today. There's a brewery there now, actually a street called Waterworks Avenue, and it's on Waterworks. So you can see people were hanging on the edge of the bank there. This building is the first artesian pumping station, and it's still there. The front half of the building is still there. St. Jude bought it, and they're preserving the building. It still says whatever the name of it is. So in 1878, after the second yellow fever epidemic, the city decided they needed to do something. You can see the way this, you can't read it from back there.
Yeah, we can read it.
30,000 people left town, 4,204 white people died, 946 African Americans. But you notice how many stayed and who took care of who. That's a big part of history that nobody wants to talk about. Black folks stayed to take care of the few white people that stayed. And and a lot of those people are buried now at Elmwood in a mass grave because people were dying so fast they couldn't separate. So they decided they would put in a sewer system. Now that was all well and good, except that's about, I don't know, 10, 15 blocks of the city up in the north part of town. So now it's expands to cover the whole city. We treat everything in this plant south of Poplar Avenue. So along the highway is a natural ridge down to Collierville. So everything from Poplar, except for downtown, they rerouted that years ago. They pump into the Stiles plant instead of us. So there's an aerial view of what we used to look like. We need to change that. We got several other pieces that you'll see out there when you take a tour. So everybody knows, everybody in this operation probably knows this is an activated sludge plant. So it's all bacteria. We don't treat with any chemicals at all. Again, this is pretty dumb and simple for most folks that already have licenses.
So the question was asked earlier, do your industries let you know when they discharge something, right?
No.
And that's a huge issue if you're an activation sludge plant, right?
There are, we have a lot of, we have 7 major industries. Industry we call major. One is really big, the other 6 are relatively small comparatively. One industry in town discharges up to 180,000 pounds of POD a day. So they're a good bit of our loadings most of the time. We also have Valero. If you came in off of Mallory, you saw Valero. They're right on top of us. Right down the street from them is Fleischman's Yeast. AB Mari now. They can't do as much damage, but they have had, and they're good about calling. I'll give them that. They're good about calling. They've had a couple of tank car eruptions, and that's molasses. So it's coming, and it's coming hard because it's close. They also have a lot of color that we can't get rid of. But if they dump more molasses, we get darker, and less, we get lighter.
Yeah.
We've got 6 1,500 horsepower blowers. Right now, we're only running 2, right? After the modification of the plant, we added fine bubble diffusers over the last 7 years. We modified our aeration basins and added a re-aeration tank. Added plastic media to all our trickling filters. So we have improved our treatment tremendously. Normally this time of year, of course, it hasn't rained. Let's all, everybody knows how bad rain can affect treatment. We're about, I just figured last year's I&I, we're somewhere around 18 million gallons for every half-inch of rain. Everything's closed. We don't have anything that's supposed to be combined sewer, but we still get about 18 million gallons of extra water for every half-inch of rain. So, but the last 3 days, our effluent TSS has been 10, 10, and 9.
10, 10, and 9?
Yeah. TSS of 10, 10, and 9.
Wow.
That's as good as we've been in years. Same deal. This picture, we did add the fine bubble diffusers. We've got 14 aeration basins full of fine bubble diffusers. It's a blessing and a curse. Dealt with fine bubble diffusers, you know this. And now we have 6 trickling filters that are full of plastic. Our biggest, like everybody else that does wastewater, our biggest consumer our biggest bill is energy. I think our January bill will probably run around $375,000. Just for the electricity. Maybe a little more.
I was gonna say, I'm gonna keep them down.
We have 6 now. We have 7 screw pumps. Thanks to Millington, we now have 6 screw pumps and a submersible pump. We have, when those were put in, they were the largest 7 screw pumps in the world. Then they put in a couple of bigger ones in Russia somewhere. Then we found out, like a lot of people that run screw pumps, that bearings are a real issue. Bottom bearing especially. Top bearing's not so much. There's a included video. This is really for kids, so y'all get the dumb and simple version. We've got 8 final clarifiers, 10 final clarifiers now. And basically the same thing. Now what happens is our return sludge goes to a re-aeration tank. So we're not actually doing contact stabilization. We're doing trickling filter activated sludge with a re-aerated activated sludge returning to the trickling filter effluent, which is odd, but it works, apparently. The only problem with that system is that, and if anybody ever offers you to do this for you, even on a small scale, be sure there's another way to get mixed return sludge out of the re-aeration tank. Because if you lose the blowers, all you've got is a tank full of unaerated sludge. We found that out the hard way. We did not include a way to get that mixed and out of there. So then, 100 years ago, or at least 15 years ago, we went through a partial flume for the effluent flow meter, except the flume was built wrong, never worked. So we ripped all that out as in the process of this construction, and we've been using our influent flow meter ever since the plant opened for flow. State's given us a waiver to do that. Now that we have the disinfection tank, it has two 30-foot flat rear flow meters. Also not the most accurate things in the world. So we're, on a good day, we're lightly eliminating colored if questions is not doing a whole lot. If they're really running heavy, we'll get a little darker. Our apparent color runs in the 2 to 500 range. And then after we do all of this, we send the slaves to covered lagoons. We don't have digesters, we just have covered lagoons for digestion. It takes about 2 years, give or take, to go through that process, hopefully. Starting this week, we're beginning the process of covering the largest open lagoon. That lagoon is open. It's 1,000 feet long, 1,000 feet wide, 1,300 feet long, about 8 feet deep. So they're gonna dredge that out and make it 3 cells that are 1,000 feet long and 375 feet wide, I think, and 25 feet deep. So we're gonna gain a lot of volume, plus 3 more covered lagoons.
It's a 5-year project. They just started on
No, it's 2 years. They have 2 years to get out of here.
it. Oh, 2 years. Okay.
So the biogas we collect, we're supposed to be sending over to the Allen plant, the new Allen gas plant for, to run in an auxiliary boiler, but they've not yet made themselves comfortable with operating biogas. Even if we were producing tons of biogas, they wouldn't be taking it because they're not comfortable yet operating it that way. For years, we sent it to the old steam plant. They put it in 2 different burners. When they put it in, initially they put in, TVA did all the work. They put in a drying system, dry the gas. It was the only one ever made like it. So they couldn't even fix it once it broke. But anyway, when it was working, they would send the gas from our lagoon up to the old steam plant. And even though they knew what they were supposed to be handling, they didn't put any stainless in it at all. It was all regular metal, so it corroded everything. And then they put stainless in, and it still corroded it, so they quit using it. Because the pH of the condensate is sub-2 most of the time.
Well, don't they do that up north? They sell biogas to the yeast plant right there too.
Yeah,
That's
it goes
still
right.
happening.
Yeah, they're doing the same basic thing. They're saying that it's a short run, they don't have as much condensation to worry about, and the yeast plant there doesn't seem to care.
I think they've got 2 boilers now. They alternate depending on the gas supply.
Right.
From my years ago.
But they're, as far as I know, they're still taking some of the gas, but I'm not sure.
Been a few years.
But we put we added 4 flares. We originally had 1 flare, we added 4 more. So we're capable of flaring about 100 million cubic feet of biogas if we have to. It might be nice if we could generate that, but we're not at that position yet because we're not wasting that much. Then we got a dewatering facility with 5 Ashbrook presses and 3 BDP presses. We're try to run 24 hours a day. And contractors coming in, gonna clean out that new lagoon with 4 centrifuges?
Yeah.
4 centrifuges back there. We'll see how that works. And then all the biosolids we retain right here. We've not lost a pound of biosolids yet. It's all out there in the field someplace. Once we get it dewatered, we've got these, we call them fingers, they're basically big levees. Run a truck across the top, dump it off the side, and then the dozer butters it out into the field. And we've been drying sludge like that since the mid-90s. So, I know that was a quick and dirty tour, but that's, most of y'all know this stuff anyway. Any questions?
With the Elon Musk thing coming on, how much is he gonna take from y'all?
Probably around 10 million gallons. We're running, we're averaging about 62 to 65 million gallons a day. She'll take 10 to 13. I think they're gonna build out to they said they're gonna build out to 15 at some point. To do it, the way that they've explained to us is it's modular. They're gonna start with 2 5 million gallon modules and move up another. If they have to.
Actually, I got an opportunity to tour the XAI. Grok is actually in that building. You know, whenever you use the artificial intelligence, that's where you're going to right now. All the rest of them are just data centers that's holding it out. Got a chance to see what the new facility is gonna be. It's called the Colossus Water Recovery Facility. Colossus. It's just a tertiary treatment. They got membrane. They're gonna have membrane filtration. They're gonna use anaerobic aeration or basins before the membrane filters, and that water is going to be supplied to TVA. I think Newport data, but they're talking about running the water line all the way up to Valero. That water itself will help relieve having to pump so much out of the artesian well. Alright, so that's one of the things. It's a benefit of it. Everything ain't being put out there about what's all gonna come from the project. There's some good benefits that's gonna come from the project. Environmentally good, sound benefits.
We wanted to do this as a joint project with TVA when they built that new gas plant, but they didn't want to have to clean it up enough. We're not equipped to clean it up as much as they wanted it cleaned up. We have a lot of dissolved solid, so that's one of the reasons they went with membrane.
Problem was the economics of it more than anything. We had the technology, we just couldn't get economics to work to make the plant viable.
Any questions? Average day flow here is 60 to 70. 67. When we get rain, we can push up to 170 MGD. But during that time, you lose treatment during that process because you're losing your detention time because of the extra flow. The plant here treats very well. Most of our soluble BOD is greatly reduced in the biotowers, and when we tour it, we'll see it. We just had them updated to synthetic media by West Tech. The whole project with West Tech. The arms themselves are controlled by air pressure, and so it's to maintain a set amount of rotations a minute. What was it? One rotation a minute?
Not even that, we're running one rotation every 7 minutes.
Yeah. So, and
7 to 14, depending on what we're doing.
yeah, and so it doesn't matter how much we pump up there, it's gonna maintain a certain speed at all times. And it has helped out with not seeing the arms looking like helicopters, because at first they would be, like we was actually up on the high floor, you'll see them moving, but now they slow. They were so slow we had to put flags on them so we can know they actually moving. So,
You could get up to 3 revolutions or 4 revolutions a minute.
yeah.
Without the air system.
Yeah. And so, the aeration basins themselves, since switching over to fine motor diffuser, we did have a few issues, and we still do now. If y'all do have fine motor diffusers, I don't know, do y'all suffer from the same issues as we do? One, the mandate for having to clean them all the time. I always have a tank out of service due to that. Another thing is just the maintenance on the pipes themselves, the clips that's involved, keeping them down there and everything. There'll always be problems with them, but they do serve a purpose. It's just the maintenance of. After the aeration basin, y'all will see the two brand new final clarifiers that we do have. They're nice, they're West Tech as well. F1 has been great. Only time I ever have a problem here at the plant really is whenever I get some type of industrial discharge that I don't know where it came from. Alright, that'd be the only problem I have. Other than that, plant does well. Operators here, y'all probably won't see them unless y'all be out there. Well, if they out there during the time while we out there. We run 24/7, 365. We never stop. It's always something here, somebody here. There is no automation to anything. We have been, the previous administration was against it, and we see the reason why. You know, coming in now. But it's good to always have eyes on everything, as y'all know, as operators, you know, sometimes you can't depend on that computer doing exactly what it's supposed to do at all times. Alright. So, as y'all know, one of the places that he did bring up is one of our industrial sources, Solate. It's a protein, they make soy isolate. That's what they do. They make soy isolate. And they have what they call wet spit flake after the process. You know, that's why we have an industrial runner, and they had made them improve that in order to reduce how much they send to us of that remaining product. But the soluble GOD that come down the line is still quite high, but we're able to handle it. Originally, the plant was 400, rated at 400, what was it, 400,000 pounds of BOD a day? 450. And now we're at what, 600? 620. We're able to handle up to 625,000 pounds of BOD a day. Alright. Hey.
Y'all completed through with all your remodel and everything y'all been doing down here for the last 6 years, 7 years?
Through is a relative term.
Yeah. I mean, it's never really a stopping point on, you know, your major upgrades up here. Yeah, but maintenance style upgrades for just a better improvement general, that's always ongoing. You know, I mean, right now we're in the process of procuring possibly 2 brand new blower motors. What is that? I think it's $130,000 a piece. Yeah, new rear blowers. And then we still got plenty of other projects coming down the line. So you can just imagine what the operating budget is. You know, at first, he said MLG bill it's 300 or something. I hadn't seen that bill before we got to the 5 motor fuses and then have to run as many blowers. Yeah, we was hitting $500,000, $600,000 every month.
Yeah, the improvements have greatly reduced our energy use.
Yeah.
And several industries have not, y'all probably have experienced the same thing in smaller scales or even larger scales. COVID knocked back a lot of stuff. We still have some dischargers that aren't discharging what they did 15 years ago. And a lot of that has to do too with water improvements. They're not discharging the volume they used to because they cut down on their water use. A couple of the bigger industries have their own wells, which is neither here nor there. I mean, we can't track them with water.
How big is your biggest line coming in?
Biggest line, 96 inch.
The interceptor's 96, it expands to 108 out here in the junction box, it comes to the plant at 108.
Yeah. Basically, you can imagine how to fix that. We had an actual cavity up the road there. And they had to shield it off, and then here it is. You bring in xylem to pump all the way around it and send it to the plant. So you what, 14 pumps? Sitting at
Takes
14 pumps. out of
diesel
it.
pumps to do it.
Yeah, in order to do that. Wow.
They, when the plant was built, the interceptor was a 60 that went right out across in front, just in front of the building here, out to the river. That was the discharge for what was an icon interceptor. There was no plant. This plant was built in 75, or finished in 75. Before that, it was all straight to the river. So the Corps decided they were going to develop this area for industry, or the city and the Corps together. So the Corps actually built the pump station, and then the city took it over. They built the levees. The only plans that we have of the sewer lines prior to this plant being built are Corps of Engineer plans that only show a proposed levee location, which is, right here behind us. But that 60-inch line, they just put our junction box right on top of it, parallel to 96. Well, up at South Cypress Creek, we're cross talking about, the 60 was on the outside toward the river. The 96 was behind it. Well, the old 60 was abandoned, collapsed, and let the pilings and everything collapse in 2000, probably in 2011 in the flood. And not long after that, 2015 is when it started. Fall of 2015 is when it collapsed. And it took us from Thanksgiving of 2015 till late 2016 to get it all buttoned back up. That's all. It was all repaired with Hobos pipe, all fiberglass. Everything we've done lately down here has been fiberglass, rather than concrete.
Was that the big hole y'all had up there with all the pumps around it right in front of the, transformer place?
No, that was, well, we've had several things going. That was right next to the transformer place.
Yeah, across the street.
We've bypassed, whether you ever heard this or not, but we moved an interceptor to put that transformer plant where it is. The interceptor went right under that, where that building is now. They want to build on top of it, so the city moved the interceptor across the street. Moved to 96. They bypassed it 96 for as long as it took them to move that interceptor across the street. And then we had to bypass when the line collapsed, and then just recently, there was a road crossing coming out of Fuller Park that collapsed. So we had to bypass that. We just finished that, middle of last year, I guess.
That took a while to get done. I think, the daily cost was $1 million a day.
The big issue with us is hydrogen sulfide. The interceptor, the longest run of interceptor that's all gravity is what comes in here at 96. A non-con interceptor runs from somewhere southeast of Hacks Cross and Winchester here. So it's about 20 miles, up between 20 and 25 miles of gravity line. So it has a lot of time, and Soleil is 10, I think where it comes into the interceptor is about 10 miles out. So it's got about 10 miles of gravity to cook before it gets here. All that VOD. And so it's in variable stages of running full. We've got a lot of growth in there. And so the hydrogen sulfide at the pump station or at the screen building can get up in the 400 or 500 parts per million. So we do a lot of venting and a lot of, they don't do anything on the interceptor without making sure that things done.
Mm-hmm.
But that also has led to a lot of corrosion. All those road crossings were put in the 70s, and they've got steel in them. It's in the collapse.
Well, that where it collapsed at Fuller, that was a steel pipe underneath there that collapsed.
Well, it was steel, it was concrete and steel.
Yeah, once the concrete chips away, the steel gonna corrode.
Right.
Yeah.
Exactly.
I mean, y'all tell me a little something about y'all. I didn't hear everybody with their name, y'all names and everything. I know some of y'all. Which one of y'all's on the water side? Just clean water.